Hello, this is Dave Litton and welcome to my Learn PMP Critical Path Analysis in under 17 minutes flat. Now I want you to imagine that it's your birthday today and that you and I work together and you've invited myself and a few of your friends to come for a drink tonight immediately after work in a local bar. You'll be there at 5 o'clock ready to buy us all drinks. Unknown to you, I've asked your friends to contribute and we've bought you a birthday card and a small gift, which I'll present to you once everyone's there. You turn up promptly at 5 o'clock, as I do. A few of your friends come 5 or 10 minutes later, some 15 minutes later, and the very last person to arrive arrives at 5:30, 30 minutes after you and I have arrived. And it's not till then that I can then present to you with the card and the small gift that we've all contributed to. Now, the length of time that everyone took to arrive depended on how quickly they could leave work, of course. But it wasn't until the last person arrived that I could actually give you your present. So the person who arrived last determined the earliest time that I could do my presentation. If you'd like to relate that to a project, the person who took the longest path to meet us all in the bar was on the critical path, since it is they that took the longest to get there. What about the people who came a little earlier, after 5 o'clock but before the last person? Well, if someone turned up at 10 minutes past 5, then they had 20 minutes to wait until the presentation. In critical path analysis, we'd say that person had some slack time of 20 minutes. Sometimes it's called float. So let me just make a few clear statements based on that example. The longest path determines the earliest time that your project could finish. In our example, the person who came in last. The longest path is called the critical path. What it actually means is time critical. Tasks on the critical path are naturally enough called critical tasks, whereas tasks that aren't are called non-critical. And by definition, non-critical tasks have some amount of float or slack. Here's a very simple example of a project. Just 4 tasks. Task A of 2 weeks in duration, Task B of 3 weeks, Task C of 1 week, and Task D of 2 weeks. Let's link them together in a very simple fashion. And if I asked you to tell me what is the earliest time we can finish this project, you'd say, well, it depends, Dave, on the longest path. Well, since Task A has got to start and has got to complete before we can finish, and Task D has got to start and has got to complete before we can finish, then these two, by definition, must be on the critical path, which leaves these two in parallel in the middle. Clearly you can see this is the longer of the two, being 3 weeks and C only being 1 week. So you'd be absolutely correct if you said that this was the critical path, Task A, B and D, like so. And if we add those up, we'll be able to see the earliest finish time based on that longest path of our project, giving us 7 weeks. In this simple example, there's another path down here, as you can see. There aren't any other path variants between the start and the finish, A, C and D, and this clearly is a shorter path, as we can see. In fact, if you add these up, it comes to 5 weeks. Therefore, in this example, C is the only non-critical task. And if you look at the difference between 7 and 5, it gives you 2 weeks. So as I said, with float or slack, this is a non-critical task and has, in this case, 2 weeks float. Now, the way in which this network is drawn is called a network diagram for obvious reasons. But there's another way of showing tasks, and that's by the Gantt chart. And this is shown by illustrating each task along a time frame. Here I've calibrated this in weeks. So if we now looked at that example as a Gantt chart, here's the first task, Task A. In this case, it's a bar whose length is 2 weeks in duration. Task B, which happens after it, is 3 weeks, starting here, finishing here. Task C is 1 week. That starts after A has finished, so that sits here with 1 week of duration. Task D can't start until both B and C are finished, so Task D must be here. And it's interesting to note that the float, it can now be clearly seen, of 2 weeks. And here I've shown Task C at its earliest point. You see, this therefore must be the earliest start point. and therefore this must be the earliest finish point. Now, by definition, critical tasks have 0 float, and it is they alone that set the earliest finish time of this or any project. Let's have a little look at task C. If it got delayed for some reason to the end of its float, it would look like this. And here, of course, this must be the latest time task C must start in order for the project to finish on time, and this must be the latest finish time that task C must finish in order for the project to finish on time. So you can see, much like a bead on a wire, that C could be at the earliest here or at the latest there, or any combination between the two. But of course, this is very unlike a typical project, so we need a recipe for success. Well, here we go. What you actually do is you do 2 calculations. One forward pass, which means starting at the left-hand side and moving from left to right, calculating as you go, and then the second pass, which is coming backwards and calculating backwards. I'll explain what that means in a minute. When you perform the first pass, what you actually get is the earliest finish date for your project. When you do the backward pass, this calculates the critical path and the slack or float of the non-critical tasks. The first thing we want to understand before we do our forward pass calculation is that we add the durations, and there's 2 simple rules going forward and 2 simple rules coming backward. Let's re-show that simple example, but this time we'll calculate it as we'd need to do. First thing we always do is to start with a 0 for the first activity or task. And what we have to do is to add the durations, so 0 plus 2 gives you 2. Now we need to use our first rule, which is carry forward for one task feeding into several. What that means is, whatever number is here, you take that number there and you put it top left of all of the activities that occur after it. So if we now add the durations, 2 plus 3 gives us 5, and 2 plus 1 gives us 3. Taking over from that, here's the 5 and here's the 3 that we saw just now. These now feed into activity D. And now we need to look at the second and final rule when doing a forward pass. Use the higher number for when you've got several tasks feeding into one, if you can see the point I'm making. Now in this case, because you'll have several feeding into one, which number do you use? Well, always use the highest number. So it's 3 or it's 5, it's got to be 5, so you carry 5 here, plus 2, of course, gives you 7. And that will be your earliest finish time. Please note that if you simply had one task after the other, and this task here finished on day or week 12, you merely carry that straight across to the next task, providing there weren't any other arrows feeding into this. That's the forward pass calculations done. Let's now do the backward pass calculation. In this case, the mantra is you subtract the durations of each task. The first thing you'd want to do is to take this number here and place it bottom right, ready for our backward pass calculation. It's conventional to put the numbers generated from your forward pass top left and right, and those from your backward pass bottom right and bottom left. So the first thing we need to do is to subtract durations. So 7 minus 2 gives you 5. Now in this case we're looking backwards, so facing here with your back to this task, looking back this way, you would see 2 tasks that this is in effect feeding from. And the rule is when we have one feeding into several, we merely take this number and we put it bottom right of the task that it feeds back into. Let's go to the final calculation then, starting again at the 2 tasks we've just seen. 5 minus 1 gives you 4, 5 minus 3 gives you 2. When going backwards, when we have several tasks that feed back into one, carry back the lowest number. We've either got this number or that number. And we always take the lowest, in this case, which is 2. So we take that 2 and we place it here. Now it's very easy. 2 minus 2 gives us 0, and we've done all of our calculations. Now it merely comes to the analysis, which frankly couldn't be easier. Just take this as an example of any one of the activities that we've just been looking at. You'll have numbers at the top here, here, here and here. What we need to look at is either the front pair or the back pair. It doesn't matter, either will give us the right answer. If the difference between these 2 numbers is 0, that must be a critical task. If the difference between either the front pair or the back pair is not 0, then it's a non-critical task, and that numeric difference will give you your float. Going back to our early start and early finish, later start and latest finish, very often, rather than just drawing a rectangle like I have, you'll have them like this, where you'll have a number here, which is the earliest start. Here will be your earliest finish. This will be the latest start, latest finish. You'll normally have your activity name in here. Float is sometimes inserted here, but it's the same principles. And as you've probably gathered by now, when you do your forward pass, you're calculating your earliest start and early finish, and when you come back and do your backward pass, you're calculating your latest finish and latest start. So that's the principle sorted. Now let's look at a typical PMP question on critical path analysis. I've called this a PMP hard question. Well, I think you'll agree it looks a lot more complicated than the simple 4 we've just looked at. Indeed, it won't get any harder than this, and as I'm going to show you, this is fairly straightforward once you understand how to do it. The key points of interest here when you come to your forward and back calculations are these here. It's only when you have multiple inputs, when you're calculating forward or back, is where you just need to be careful, and it only takes a few seconds. Remember, all you need to be able to do is to add the durations going forward, subtract them coming back. And when it comes to choices, when you do your forward pass, it's the highest number that counts, and when you're coming back, it's the lowest number. Believe me, it's no harder than that. So let's go through this exactly how you'd want to do under exam conditions. First thing, of course, is you take your first task, and what do? We put a 0 there, and we add the duration. Now this obviously feeds into 3 tasks. I notice that this has got 2 arrows going into it, so I'll leave that for the moment. Let's do the easy ones first. We take this 7, when you have one task feeding into several, we take that 7 and put it straight up here, add it to the duration, making 13. 7 also goes down here, add it to the duration, making 9. When you've got 2 tasks simply one after the other with only 1 arrow in it, just simply carry that across 13, add it to the duration, and you've got 20. In the middle here, you see this has got 2 arrows coming into it. This shows a time unit of 7, but this shows 9, and the rule is use the highest number. So it's the 9 that comes here, not the 7. In a similar way, 9 plus 4, adding durations gives you 13. Down here, again, it's only 1 input, so you carry that 9 straight across, add it to the duration, gives you 19. Now we're coming to some of our multiple choices here. Keep a clear head, it's very straightforward. Look at E. It has 4 inputs. So all we have to do is to follow the arrow back and see which is the highest number. So out of the 4, 20 is the highest, so it's 20 that will come here. Plus 9 gives you 29. Now task H, the final one, is fed from 3 tasks, again which is the highest. So it's 29 which wins the day. So it's 29 we put here, plus 8 gives you 37. And this, of course, is your project earliest finish time. Now, this is a so-called hard question. That wasn't very hard at all, was it? What do we do now? We now need to do the backward pass calculation. So we're going back this way. First thing we need to do is to take this 37 and bring it down here. And what do we do in the backward pass? We subtract duration. So 37 minus 8 gives us 29. Now remember, when we're calculating backwards, ignore the direction of the arrowheads. We're merely looking at linkages. And task H has 3. Now before you go sticking numbers in, I'd note here which of these 3 has only got 1 arrow coming from it. And it's task E. So I know I better take that 29 and pass it back straight to there. But I notice these 2 here have also got other arrows emanating from them. So I won't want to put that 29 down here until I've worked out which of these 2 is the lowest. The same reason up here. So the first one I would put in is that one, carrying the 29 back and then subtracting the duration, giving us 20. This task has 2 feeding back from it. And when feeding back, it's the lowest number you'd use. So it's the 20 that goes down here. Minus 10 gives you 10. Can you see why I waited until I had this calculated before I made a decision? Let's do the same up here. Can you now see this has got 29 feeding into it, whereas this has got 20 feeding into it. So it's the lowest number, which is the one you choose, giving us 20 here. Minus 7 gives you 13. Now the next one is easy because this feeds back into D, and it's only got one arrow coming from it, so we can simply take that 20 and feed it back here. Minus 4 gives us 16. Now we can deal with this task here, B. It has 13 coming from it, and it has 20. And because in this case 13 is the lowest number, that's what we put here. 13 minus 6 gives you 7. In the same way, I'm going to look at F next. It has 10 coming in and 16. So it's the lowest number, so 10 wins the day. 10 minus 2 gives you 8. Well, we're just about done. How easy was that? Final decision to make. This task has 3 feeding back into it. It's got 8, it's got 16, and it's got 7. The lowest number wins, so it's 7 that's put here. Minus 7 gives you 0. Job done. Now, the final bit is the analysis. Which of these tasks are critical, which tasks are non-critical, and how much float have the non-critical tasks got? Can you see immediately that this is 0, 0 or 7, 7? Either looking at the front pair or the back pair would tell you this is a critical task. So let's just redraw this, showing the critical path. And of course, by definition, any tasks which are critical have 0 float. So these are the critical tasks. And the non-critical tasks are these here, simply by looking at the difference between these numbers. Just finishing it off, colouring it in, there's your critical path. And my friend, you've just mastered how to pass a PMP critical path question. Well done. My name's Dave Litton. It's been my pleasure to share this with you. And if you want to find out more information, just visit my website.